Hello everyone, welcome to my presentation. Today I'm going to be talking about web security. Specifically, how hackers use the tool called Burp Suite to attack websites that aren't properly secured. By the end of the video, you're going to understand how hackers and attackers intercept login credentials, how they can manipulate data being sent to the server, how they can completely bypass a login page without even knowing the password. Now, before I get into everything I'm showing today is purely for educational purpose. I'm running all this on my own local machine designed to be hacked for learning. Never use these techniques on a real website you don't own. This is illegal. So let's get into it. So first, what is web security? Every single time you visit a website, your browser is sending and receiving information back and forth to the server. That could be your username, your password, your credit card number. All of it is traveling across a connection. If the connection isn't set up securely, or if the website has a vulnerability in its code, and an attacker can sit in the middle of that traffic and see everything. They can see your credentials, your access databases, bypass logins, or inject malicious code. This is why web security matters. This is exactly what Burp Suite help exposes. What is Burp Suite? Burp Suite is a web security testing platform made by a company called Port Swiggers. It is used by ethical hackers called penetration testers to find vulnerabilities in websites before the bad guy do. But it's also used by malicious hackers for the exact same reason. Think of it as a magnifying glass seen between your browser and the internet. Every request your browser sends, every response your server sends back, Burp Suite sees all of it. And let's modify it in real time. For my demo, I'm using OWASP Juice Shop. This is a fake online store that is built fully for security vulnerabilities. It's maintained by OWASP, the Open Web Application Security Project, and is used by worldwide students and security professionals to practice legally and safely. Right now, I have it running here on my local machine on a VM on localhost 3000. As you can see, it looks like a completely real e-commerce website. It has products, shopping cart, user accounts, everything, but underneath is packed with vulnerabilities. And that's exactly what we're going to exploit for demo 1. So for this one, we're going to intercept a login request. I'm going to show you how Burp Suite intercepts a login request and why that is dangerous on an unsecured website. I've got Burp Suite open here and configure my browser to route all the traffic through Burp Suite on a proxy 8080. What this means, everything my browser sends to the internet has to pass through Burp Suite. I'm going to go to the Juice Shop login page and type in a fake email and password. Now, watch what happens in Burp. Burp has completely stopped the request before it even reached the server. And look at this. Right here, in plain text, I can see the email address I typed and the password I typed. Now, why does that happen? When you submit a login form, your browser packages that information into what it's called an HTTP post request, and it sends to the server. If the website is using a HTTPS correctly, the data is encrypted in transit. So even if someone intercepts it, they'll see gibberish. But if the connection isn't properly encrypted, or if the attacker is already positioned between you and the server, like on a public Wi-Fi network, they can see exactly what's being sent, just like this. So this is why you should never log into sensitive information on public Wi-Fi's, and why developers must always enforce HTTPS. Next demo, this is probably the most well-known vulnerability of all time. SQL injections. I'm going to log into this website as an administrator without knowing the password. I'm going to type this text into the email field. This is called an SQL injection payload. Let me type any random password and hit login. And just like that, I logged into that administrator. I didn't know the password. I didn't brute force anything. I just typed a specific string into the text box. So let me explain exactly why this works, because it's an important part. When you log into a website, your browser sends your email and password to the server. The server then runs a database query that looks something like this. On a normal login, it fills in your actual email and password, fills your account, and logs you in. But what I typed was this. The single quote at the start closes the email field early in the query. Then, or 1 equals 1 is a condition that is always true. 1 always equals 1. That's math. It just does. Then the double dash comments out the rest of the query, including the password check completely. So the database queries gives me a user where the email closes here, or where 1 equals 1, which is always true, and then ignores everything after that. The database returns the first user it finds, which is administrator, and the server logs you straight in. This happens because developers took users' input and pasted it directly into the database query without sanitizing it first. The fix is something called parameterizing queries or preparing statements, where the database tests users' input as data only, never as part of the actual query code. This is one of the most preventable vulnerabilities in existence, and it's still found in real websites today. Next demo is I'm going to show you something really interesting. What happens when a website turns that data that comes from a client without verifying it on the server? I'm going to add a product to my cart here in Juice Shop. Burp has intercepted the request. Now look at this. I can see data being sent to the server, including the price of the item, which what happens when I change the value. I forward the modification request to the server. And now let's check the cart. The price changed. The server accepted whatever I sent it. So why does this happen? A lot of websites make the mistake of calculating a price or quantities on the client side, meaning in the browser, and then just sending the value to the server. The server receives it and goes, okay, the client said it costs this much. I'll trust that. That's a massive vulnerability. The fix is called server-side validation. The server should always independently calculate the price based on what it's in its own database. It should never trust a piece that comes from the user browser. This kind of vulnerability can be used to purchase items for free, manipulate loyalty points, or change quantities to negative numbers for refunds. So how do we stay protected? So now you've seen how these attacks work. Now let's talk about what developers can do to prevent them. Number 1 is always use HTTPS. This encrypts your traffic, so interception data is useless. Number 2, validate everything on the server side. Never trust what the client sends you. Always recalculate prices, qualities, and permissions from your own database. Number 3, use parameterized queries. Never build database queries by connecting user input directly into a string. Number 4, test your own applications. Use tools like Burp Suite ethically on your own projects to find these vulnerabilities. before someone else does. And number 5, study the OWASP Top 10. It's a free list of the 10 most critical web vulnerabilities update, regulated by security professionals. SQL injections is on there, and this is a broken authentication. So is broken authentication. Sorry about that. If you're building anything web related, that list is required reading. And that's a wrap. Today, we cover what Burp Suite is, how it works as proxy, and we did 3 live demonstration OWASP Juice Shop. We intercept login credentials, manipulate request data, and bypassing authorization with SQL injection. The big takeaway here isn't how to hack. It's understanding why these vulnerabilities exist so that as developers and security professionals, we can build things that don't have them. And remember, only ever test on systems that you own or have written permission to test. Using these tools on real websites without authorization is a federal crime.